Hello viewers, this is Ronald taking you through the story for A-Level Pure Mathematics. And this video we are going to go through the solutions for Uneb 2019 of paper 1. So we'll start with question 1. Question 1 says that show that the modulus of this is equal to 4 root 2. So first of all, this is the quotient or division. Therefore, modulus of a quotient is equal to modulus of numerator divided by the modulus of denominator. So it's the modulus of the numerator and it's the modulus of the denominator. So for the numerator, you'll first leave this bracket alone, this power alone, and deal with the modulus of this inside the bracket. So modulus of 1 minus I is equal to the square root of 1 squared plus negative 1 squared. So after getting the modulus of this inside, I'll come and bring back the power, which is 6. Then modulus of 1 plus I is the same as square root of 1 squared plus 1 squared. So next simplify this in bracket to gives me root 2, and therefore bring back the power, which is power 6, and the whole of this is root 2. So this is same base, so what we shall subtract the powers. So subtracting the powers is the root 2 in raise the power 6 minus 1, which becomes power 5. Now root 2 to power 5 is the same as 4 root 2, and that's what they wanted. So now let's see how marks can be awarded. So M1 for modulus of numerator, another M1 for modulus of denominator, B1 for the output of both numerator and denominator, M1 for these indices, and A1 for the output. So the question required getting modulus of complex numbers and applying the properties of modulus. So it was not a very popular question, and the weakness of candidates is that lack of knowledge of properties of modulus. So modulus of a quotient is equal to modulus of the numerator divided by modulus of the denominator. They expanded the numerator, which made it more difficult to obtain its modulus. So expanding becomes more tricky because that I is equal to negative square root is not easy to deal with. So the advice to teachers is that emphasize the use of properties of modulus and the use of arguments of complex numbers where there are higher powers. So you can first express the complex number in modulus argument form. This is what they mean by this second step. And this one, use of properties, the one you have done in the question by getting the modulus of the numerator alone over the modulus of the denominator alone. So that was question 1. Now we shall go to question 2. Question 2, they wanted to solve this where theta is greater than 0, greater than or equal to 0, and less or equal to 360. So that is the given equation. First of all, you shall realize that this is a double angle, so changing it into half angle to become 2 cos squared theta minus 1. The next is to open brackets to come up with this by 2 is that, and this by 2 is that. So next is to get a quadratic equation by bring this for this side to come up with negative 6. Then you shall look for factors whose sum is negative 5 and product is 4 times negative 6, which is negative 24. So those factors are negative 8 and positive 3. So what we shall do, we shall replace this with this. So negative 5 will be replaced by negative 8 and positive 3. So next we shall pair this alone and this alone. So this one alone, the common factor is 4 cos theta, so we shall pull it out and remain with cos theta minus 2. And for this side, the common factor is 3, so we shall pull it out and remain with cos theta minus 2. So I think we realize that these two are the same, therefore we shall come up with 4 cos theta plus 3, which is that in one bracket and another bracket you shall have cos theta minus 2 equal to 0. That means that either this is equal to 0 or this is equal to 0. Now for this equal to 0, cos theta is 0.75, and for this equal to 0, cos theta is equal to 2. When I use a calculator, our cos of 0.75 is 41.41, but remember this cos is possible in the first and fourth quadrant, therefore the next angle will be 360 minus 41.41 to give you 318.59. For this side, our cos of 2 is undefined, so we shall say theta is undefined. Then we shall come and list down with the required angles, which is 41.41 and 318.59 degrees. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 for this double angle or half angle, M1 for this quadratic equation, M1 for factorization, B1 for the values of cos, and A1 for both angles. So the question required use of trigonometric identities, that is double angle, to solve quadratic equations with mixed angles. It was a very popular question, and the weakness of candidates is the use of calculators to solve intermediate quadratic equations. So you must never use calculators to solve quadratic equations. Either use bulldozer method or factorization method. So also another weakness that candidates fail to list the angles within the required range. So you must first know the quadrants where the angle lies. Advice to teachers is to emphasize reading of angles in all the appropriate quadrants. Then caution students against the use of calculators to solve quadratic equations. So you must never use a calculator to solve quadratic equations. So now we shall go to question 3. Question 3 says that use the substitution u equal to arctan x to show that this integral is equal to pi squared over 32. So the good thing, they've given us the variable to use. So what you're going to do, shall first set that variable and then bring this arctan this side to come up with x equal to tan u. After that we shall differentiate. When I differentiate with respect to u, I come up with dx du being equal to sec squared u. So differentiate tan, I'll come up with sec squared. Make dx the subject by cross multiplying to come up with sec squared u du. So now we have got this dx. Next we have to change these limits. So we shall first draw something like a table. So we have values of x. So values of x, we shall put this and this. We shall put this 0 here and also this one here. So next is to get the corresponding values of u. So the corresponding values of u, to get them, we are going to bring this x and substitute it here. So when I substitute it there, I'll come up with u being equal to arctan 0. So arctan 0 is 0, that's why you put 0 there. Then next bring this 1 and put it here. You'll come up with u equal to arctan 1. So arctan 1 is pi over is 45 degrees. But remember, for integration we don't use angles in degrees, we use angles in radians. So 45 degrees has to be converted to radians to come up with pi over 4, which is there. So next, now that you have got limits and the dx, you can now substitute. So remember, arctan x is u, so where there is arctan x, we shall put there u. And also x is tan u, so where there is x, we shall put there tan. So therefore x squared is equal to tan squared u. Then where there is dx, we shall put there sec squared u du. So this dx will be substituted with sec squared u du. So we have finished substituting. Next is to simplify. So when you simplify, you realize that 1 plus tan squared u is equal to sec squared u, that's why it is there. Then next you can realize that this and this can cancel to remain with only u, which is there. So when I integrate u, I'll come up with a half u squared. The limits also, don't forget them, 0 to pi over 4. So next is substitute the limits. So when I substitute pi over 4 here, I'll come up with this. And when I substitute this 0 here, I'll come up with that. So next is to simplify, open brackets. So pi squared is this, and 4 squared is 16 times 2 to give you 32, which is there. So basically that's what they wanted. Now let's see how marks can be awarded. So this M1 for getting dx and this and changing the limits. Then another M1 for changing variables, M1 for integration, M1 for substitution, B1 for the required expression. So the question required use of a given change of variable to show the value of the given definite integral. So the question was popular, but the weakness of candidates is the conversion of limits and representing them in radians was a challenge. So converting the limits was a challenge to many, because most candidates left the answers in degrees and they integrated from 0 to 45. Then two that candidates failed to change the variable. So advice to teachers to emphasize that whenever change of variable is required for a definite integral, the limits must be changed at that point. Note this word, at that point. Most students maintain the old limits even after changing the variable, so that will be not okay. So that was question 3. Now we shall go to question 4, which says that given that the plane 4x plus 3y minus 3z minus 4 equal to 0, part A, show that the point 1, 1, 1 lies on the plane. Then 2, find the perpendicular distance of the point of the plane to the point 1, 5, 1. So we shall start by showing. So showing, we are going to substitute for x, y, and z. So this is the x coordinate, put it here. So when I put it there, it will come up with this. This y coordinate, put it here to come up with this. This z coordinate, put it here to come up with that. So next is simplify. We realize that 0 is equal to 0 and shown. Now we shall go to part B. Part B, the one the perpendicular distance of the plane from the plane to the point that. So that formula can be quoted from the mathematical table. So what we do, for the numerator, you are going to write the whole of this, but you have to remember to substitute for x, y, and z. So how do you substitute? You will come here and get this x coordinate and put it there. That's why there is 1 here. Then get the y coordinate and put it here. That is why there is 5 there. And get the z coordinate and put it here. That is why there is 1 there. So that's how they get the numerator. What about the denominator? For the denominator, you get the coefficient of x, y, and z. So coefficient of x is 4. That is why there is 4 squared here. Coefficient of y is 3. That's why there is 3 squared here. Coefficient of z is negative 3. That's why there is negative 3 squared there. Everything under square root. So next is to simplify. So when I simplify, numerator will give me 12 and denominator will give me root 34. But an answer cannot be left when the square root is in the denominator. So we have to rationalize to come up with 12 root 34 over 34, which has simplified to come up with 6 root 34 over 17 units. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 for this substitution, B1 for output, M1 for this substitution, M1 for simplifying, and A1 for output. So the question required to find perpendicular distance of a point from a plane, and the question was popular. However, candidates failed to distinguish between the verbs showing and verifying, and also they failed to use the formula for a perpendicular distance from a point from a plane. So the advice is to emphasize the use of mathematical tables, because this formula is quoted in the mathematical tables. Then 2 is to use examples to illustrate the difference between verification, showing, and proving. So that was question 4. Now question 5 says, find the equation of the tangent to the curve y equal to a cubed over x squared at the point P, which is a over t, a.t. squared. So first of all, this is the given equation. So you have first used negative indices to come up with a cubed x power negative 2. So this one has come up. so that we can easily differentiate. So to differentiate, we have bring down the power. So bring down this power here, which is this. Reduce the power by 1 to come up with negative 3, x power negative 3. Then this a cubed remains there. So next I'll make this power positive by getting a negative 2a cubed over x cubed. So I'm done with differentiating. Now this derivative is the gradient function. So to get the gradient, you have to substitute for x here. Remember, x is a over t. So I'll come here and substitute for x. So negative 2a cubed is here, then divide by x coordinate, which is a over t, but it has to be cubed, which is there. So when I make this one multiplication, I have to get the reciprocal here, so that's why you see here t over a cubed. Then this one and this can cancel to come up with negative 2t cubed. So that is the gradient at point P. Therefore, the equation of the tangent is equal to change in y over change in x, so equal to the gradient. So change in y will be y minus e.t.c squared, which is this. Change in x will be x minus a over t, which is that. So that gives you the gradient, which is that. So next is to cross multiply and simplify to come up with y equal to negative 2t cubed x plus 3at squared. So basically that's what they wanted, and now let's see how much can be awarded. So M1 for the derivative, M1 for substitution, B1 for the output, M1 for equating gradients, and A1 for the equation of the tangent. So the question required use of differentiation to find the equation of tangent to a given curve at a given point. So the question was very popular. However, candidates failed to differentiate the given function. Simply because it has a negative, you had to first bring up the power to get a negative power. So candidates failed to see that. Then also candidates used gradient function as the gradient at a given point to find the given equation of the tangent, which is not okay. Remember, gradient function still has x, which is variable, so it still has x. So what you do, you have to substitute the point, the coordinate of that point at the coordinate of a point to get the gradient. So remember that gradient function is not the same as the gradient. Gradient function is general, but the gradient is specific at a given point. Then advice to teachers is to guide students on finding gradient function by either implicit or parametric differentiation. Then also finding gradient at a point before substitution in equation of a line. So teachers would advise students to find gradient at a point before substituting into equation of a line, because otherwise students will not get the answer correct. If you substitute this gradient function before substituting the point, that will be wrong. So that was question 5. Now we shall go to question 6. Question 6 says that given that alpha plus beta is equal to negative 1 over 3 and alpha beta is equal to 2 over 3, form a quadratic equation whose roots are alpha over beta and beta over alpha. So for you to form a quadratic equation, you have to first get the sum of roots and also product of roots. So let's begin with the product of roots. So product of roots, you come up with this. In this case, you realize that this alpha cancels and this one also cancels to come up with 1. So what about sum of roots? So sum of roots is this plus that. After this, we shall get LCM, which is alpha beta. Then alpha beta divided by beta is alpha. Alpha times alpha is alpha squared. Then also alpha beta divided by alpha, we get beta. Beta times beta is beta squared. So now we have alpha squared plus beta squared as the numerator and alpha beta as the denominator. So expanding this in terms of sum and product is the same as alpha plus beta squared minus 2 alpha beta. So next to substitute, you already know that alpha plus beta is negative 1 over 3, which is that, and this product is 2 over 3, which is that. Then divide by this product, which is 2 over 3. Next is to simplify. So when I simplify, I'll come up with the whole of this will be equal to negative 11 over 9, and this one outside 2 over 3. Because this is multiplication here, it means we shall get the reciprocal for this, which is 3 over 2. So next is to come up with that as the sum of roots. So now that I've got sum and product of roots, therefore the required equation will be given by x squared minus sum of roots x plus product of roots, which is equal to 0. So when I substitute, for sum it will be that and product will be that. So make it multiply through by 6, which will come up with 6x squared plus 11x plus 6 equal to 0. So basically that's what they wanted, and now let's see how much can be awarded. So B1 for the product of roots, M1 for expression for sum of roots, and M1 for substitution, B1 for output, A1 for the required equation. So the question required forming a new quadratic equation given the sum and product of roots of an original quadratic equation. So the question was very popular, however, candidates failed to obtain the sum of new roots. So the sum of new roots was a challenge to many. Also they failed to substitute the negative sum of the new roots in the standard form, and also to write a proper quadratic equation. So the advice is that teachers should expose students to all aspects of quadratic equations, and also handle fractions and negative sum of roots. So that was question 6. Now we shall go to question 7. Question 7 says, find the area enclosed between the curve this and the x-axis. So the first thing to do is to get the limits to use. So at the x-axis, y is equal to 0, so come and substitute for y. So where there is y, you put 0 to come up with that. Then you will factorize out 2x is common, you remain with x minus 2. That means that x is equal to 0 or x is equal to 2. Now this will be our limit. So the smaller one is the lower limit, upper one, bigger one is the upper limit. Therefore the area of the curve can be got by first sketching. So when I first sketch, I'll come up with that, and that shaded part is the required area. So now we shall come and say that the area is equal to the integral from 0 to 2. 0 to 2 are these limits, which are the x-intercepts from the integral of this y. So y is this, so that's what we shall integrate. So when I integrate, I'll come up with that. So integrate 2x squared, I'll come up with 2 over 3x cubed. Integrate 4x, I'll come up with 2x squared. So next I'll substitute the limits. So when I substitute the upper limit here and here, I'll come up with this. Substitute the lower limit here and here, I'll come up with that. So next is to use the calculator, and I'll come up with negative 8 over 3. What does that mean? It means that the required area is this below the x-axis. So when you're stating, you ignore you don't remove the negative, but so because the negative shows that it is below the x-axis, as you can see it here. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for factorization, and B1 for the intercepts, M1 for integration, this for substitution, and this for the required area. You have to state the required area. So the question required finding the area bounded by a given curve and the x-axis. It also required interpreting the negative sign resulting from the integration as area below the x-axis. So the question was a popular question, and the weakness is that candidates failed to identify the limits of integration. They failed to realize that the x-intercepts will act as the limits. Then 2, use the correct element of area required. So they failed to use the correct element of area required. And also interpret the negative result from the integration as area below the x-axis. So most candidates did not conclude. So you remember, you have to conclude to get that last mark. Then advice to teachers is to emphasize the relevance of a sketch in finding the limits and the correct area. So that was question 7. Now we shall go to question 8. Question 8 says that given that Q is equal to this and E is equal to that, so this dot means multiplication. Find E when P is equal to 600. So when P is equal to 600, Q will be equal to, so we'll come and substitute for P here to come up with that. Therefore Q is equal to square root of 20. But remember, they want you to find E, and E is equal to dp dq, negative dp dq multiplied by P over Q. So we have got P, we have got Q, but we have not yet got dq dp. So you are coming and say that from Q equal to that, Q squared is, when I put square on both sides, I come up with Q squared equal to 80 minus 0.1p. Then when I differentiate both sides with respect to P, I'll come up with 2Q dp equal to negative 0.1. Then when I make dp dq the subject, I'll come up with negative 0.1 over 2q. Therefore when P is equal to this, Q is equal to root of 20. Therefore when I substitute, I'll come up with E being equal to that. So dp dq is that, and P over Q is that. So next is substitute for P and Q. So Q is that, so I'll put it there, and P I'll put it here. And when I do that, this is what I'm going to come up with. And when I use a calculator, I'll come up with that as my answer. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for the value of Q, M1 for the derivatives on both sides, so this and that. Then M1 for substitution into E, so this part, and A1 for the value of E. So the question required differentiation of a function and substitution of a given value in a given function. So the question was not popular. So students were used to differentiating a function only, but this time it was a function of a function. Then the weakness is that candidates failed to differentiate a function of a function involving other variable letters other than x and y. So most students are used to x and y. The advice to teachers is to guide students how to manipulate variables with different letters in analysis. So that was section A. Now we shall go to section B, which carries 12 marks each and has 7 questions where a candidate is expected to answer only and only 5. But for the sake of revision, all the 7 questions will be answered. So we shall start with question 9. Question 9 part A says, determine the perpendicular distance of the point this from the line that. Then part B, show that the angle theta between two lines with gradients this and this is given by theta equal to arctan that. Hence find the acute angle between the lines this and that. So just start with part A, where they want the distance of a point from a line this, a point this from a line that. So the formula for perpendicular distance is also got in the mathematical tables. What you do, you substitute for the point x coordinate and y coordinate in the equation of the line over the quotient of the x and y. So the quotient of x was 2, quotient of y was 4 squared and everything under square root. So when I simplify, I come up with 29 over root 2, but you can't leave a square root in the denominator, so you have to rationalize to come up with that 29 root 5 over 10 as the answer. Now for part B, we shall say that if the lines with gradients this and this makes an angle theta 1 and the line with gradient this makes an angle theta 2 with a positive axis, then it implies that lambda 1 is equal to tan theta 1 and lambda 2 is equal to tan theta 2. Therefore, we can show that with a sketch. That is theta 1, then that is also theta 2. Therefore, the angle between them is theta 1 minus theta 2. So before we use it, let's see how marks can be awarded for this slide. So this M1 for substitution, M1 for simplifying, A1 for rationalizing, and output. Then for part B, this for getting both lambda 1 and lambda 2. Therefore, the angle between the two lines is theta 1 minus theta 2, as we already seen. Then we shall substitute, put tan on both sides, we'll come up with that. Therefore, when I expand, this two will give me tan theta 1 minus tan theta 2 over 1 plus tan theta 1 tan theta 2. But I know that tan theta 1 is lambda 1, tan theta 2 is lambda 2. Therefore, I come and substitute for tan theta 1 and tan theta 2 to come up with that. When I make theta the subject, it will be equal to arctan lambda 1 minus lambda 2 over 1 plus lambda 1 lambda 2, which was required. So next they wanted you to get the angle between two lines. So for this line, lambda 1 is that. So the gradient of this line is negative 1, and for this line, this gradient is root 3. Therefore, the acute angle will be got from this formula. Therefore, we shall come and say that when I call that formula, I'll come and substitute for lambda 1 and lambda 2. Lambda 1 is that, lambda 2 is that, lambda 1 is that, lambda 2 is that. Therefore, when I simplify, I'll come up with that, and when I use the calculator, it will be 75 degrees. So basically, that's what they wanted. Now let's see how marks can be awarded. So M1 for putting tan on both sides, M1 for expansion on the right hand side, M1 for substitution, B1 for the required expression, M1 for the value of lambda 1, M1 for the value of lambda 2, M1 for substitution, A1 for output. So part A required to find the perpendicular distance of a point from a line, and part B required the relation between the gradient and tangent of the angle between a line and the positive direction of x-axis, and also to use the formula for angle between two lines. Then both parts were not popular, so candidates failed to apply the formula for perpendicular distance of a point from a line, yet it is there in the mathematical tables. Then two candidates failed to generate the equation for the angle between two lines. So I advise that teachers should emphasize the use of formula or in mathematical tables, because these formulas are there. Then to illustrate the relationship between gradient and the tangent of the angle between the line. Remember that gradient is equal to tan that angle between the line and the positive direction of x-axis. Then derive the formula for angle between two lines. So that was question 9. Now question 10 says, part A, given that 26, given that the whole of this is equal to a root 3, find the values of A. Then part B solves the simultaneous equations, this and that. So we shall start with part A. So for part A, what we shall do, we shall first get the LCM to combine these two to get the LCM, which is 26 squared, which is there. So numerator will now be, for this side, to become 26 squared, because 26, this is as if it is 1 over 1. So this LCM, which is 26 squared divided by 1, is 26 squared, multiplied by 1 remains 26 squared, which is there. For this other part, 26 squared divided by 26 squared is 1. 1 times 1 is 1, which is that. So when I simplify, when I say this minus 1, you come up with 675 over 26 squared. But remember, there is power half. So that power half means square root. So square root of this will be plus or minus. So you should remember that, plus or minus 15 root 3 over 26. So this and this will cancel to remain with plus or minus 15 root 3. Therefore, what does that mean? It means that A will be equal to plus or minus 15, which was, so those are the two values of A. Remember, they wanted two values of A. So most students forgot this, and that makes it not okay. So that was part A. Now we shall go to part B. So part B, we are given two equations and they want you to solve them simultaneously. So from this, you can choose to pair. When I pair these two, I'll come up with this. Therefore, y is equal to 2x over 3. Then when I pair this with this, I'll come up with this. Therefore, z is equal to x over 2. Now that I've got y and z in terms of x, I can come and substitute for y and z in the second equation. So when I substitute, I'll come up with that. Now I have only one unknown, which is x in this equation. So I have to simplify and get the quadratic, which I can solve. So basically now this is the quadratic. Is better when the a has a positive value. So before we go to the next slide, let's see how marks can be awarded for this slide. So M1 for combining into one fraction, which is that. M1 for simplifying. A1 for the square root. Then B1 for the output. Another B1 for the value of A. Then B1 for y and z in terms of x. M1 for substituting. M1 for quadratic equation. So now let's see how we can solve that quadratic equation. So the factors are positive 6 and negative 4. So we shall come and substitute them there. Therefore, when I start pairing, I'll pair these two to give me this, because 3x is common, and pair this to give me this, because negative 4 is common. Therefore, in the end, I'll come up with 3x minus 4, which is that, and here it will be x plus 2. Therefore, x is equal to 4 over 3, or x is equal to negative 2. Now, for x equal to 4 over 3, what are the values of y? So y will be that, and z will be that. What about for x equal to negative 2? Y will be that, and x will be that. So basically that's what they wanted. Now let's see how the marks can be awarded. So M1 for factorization, A1 for both values of x, A1 for both values of y and z here when x is that, and so on A1 for both values of y and z when x is that. So the question part A required the use of algebraic equations to simplify a given expression, and part B required solving simultaneous equations with 3 unknowns. So the weakness of kindness is that they failed to obtain the positive and negative values of square roots. Then also to express equations in one variable. So advice to teachers is that emphasize the positive and negative values of the square root, and also expose students to solving miscellaneous simultaneous equations. So that was question 10. Now we shall go to question 11. Question 11 says that express 7 cos 2 theta plus 6 sin 2 theta in the form r cos in brackets 2 theta minus alpha, where capital R is a constant and alpha is an acute angle. Or they say that hence solve 7 cos 2 theta plus 6 sin 2 theta equal to 5 for angles of theta from greater than or equal to 0 degrees but less or equal to 180 degrees. So the first thing to do is to equate the two, so we shall say that 7 cos 2 theta plus 6 sin 2 theta is equivalent. Now this word equivalent to r cos in brackets 2 theta minus alpha. So next is to expand r cos 2 theta minus alpha. When we expand, we shall come up with r cos 2 theta cos alpha plus. So this is a plus, so when this is a minus, here it will be a plus. Plus, so r sin 2 theta sin alpha. Now next is to compare. We realize that this here there is 7 alone and here there is r cos alpha. Then here, then we cancel this, they remain with 6 here and here remain with r sin alpha. So what does that mean? It means that by comparison, r cos alpha is equal to 7 and r sin alpha is equal to 6. So that's where this step is coming from. Now we have two equations and two unknowns. So what we are going to do, we are going to first divide both. So we shall say this divided by this, you'll come up with r sin alpha over r cos alpha, and this side there will be 6 over 7. Now this r will cancel, so you remain with sin alpha over cos alpha, which is equal to tan alpha, and this will remain, which is 6 over 7. Now alpha will be tan 6 over 7 to come up with 40.60, so rounded off to 2 decimal places. That we also know that r will be equal to the square root of this and plus the square root of that, because we know that cos squared alpha plus sin squared alpha is equal to 1. The square root of this will give you square root of 85, so that is our value of r. Then next we are going to replace that r here and this alpha there to come up with this being equivalent to root of 85, which is this r cos 2 theta minus 40.6, which is that. So before we go to the hence part, let's see how much can be awarded for this step. So B1 for expanding, and B1 for getting the value of alpha, B1 for getting the value of r, and B1 for getting the required expression. So now we shall go to the hence part. So for the hence part, we are given that this is equal to 5. So we already got this expression in terms of r cos 2 theta minus alpha. So you come and replace and say that a root of 85 multiplied by cos 2 theta minus 40.6 degrees will be equal to 5. So when I make cos the subject, I'll come up with cos 2 theta minus 40.6 degrees being equal to 5 over root of 85. So I'll brought this one this side. Now next is to get arc cos. So arc cos of 5 over root of 85 will give me the value of 2 theta minus 46 degrees, and that will be 57.16 degrees. But remember, cos here it is positive, so cos is positive in the first and fourth quadrant. So in the fourth quadrant, the value of 2 theta minus 40.6 degrees will be equal to 360 minus 57.16. So when you do that, you will come up with 302.84. The next, my aim is to get theta, to make theta the subject. So for me to do that, I'll first take this side. So when I add 40.6 to 57.16, I'll come up with 97.76. Also, when I add 40.6 to 302.84, I'll come up with 343.44. Now next is to divide throughout by 2 to come up with theta. So that means that when I divide 97.76 by 2, I'll come up with 48.88. And also when I divide 343.44 by 2, I'll come up with 171.72 degrees. So basically that's what they wanted, and now let's see how marks can be awarded. So this M1 for substituting, then M1 for making course the subject, and here B1 for each value, so B1 for this and B1 for that. Then also B1 for each value, so B1 for this and B1 for that. Then A1 for each, so A1 for that and A1 for that. So the question required expressing the sum of simple trigonometric functions in a compound angle form and using it to solve the given equation. So the question was very popular, meaning it appears frequently in the previous past papers. However, there are some weaknesses found in candidates. One is the difficulty in reading all the angles, so all the angles in the given range. Then 2, they failed to compare the coefficients in the equation, so you have to compare. That's why you said by comparison. Then 3 is that over approximation of root of 85. I think realize that my root of 85, I left it as square root of 85, so some approximated to 1 decimal point, which will be 9.0, which is not okay. So this is called premature approximation. The advice to teachers is to guide students to expand and compare coefficients. Then 2 is to work out all the angles within a given range. So that was question 11. Now we shall go to question 12. So question 12 says that given that y is equal to ln or natural log of ex multiplied by x over 2 or x minus 2 over x plus 2, everything raised to the power 3 over 4, show that dy dx is equal to x squared minus 1 over x squared minus 4. So part B, they say that evaluate the integral from 0 to 4 of dx over x squared multiplied by square root of 25 minus x squared. So part A, we shall say that when I expand, this will be y will be equal to ln ex plus 3 over 4 ln x minus 2 minus 3 over 4 ln x plus 2. So product is when you expand, it becomes addition. Then division, when you expand, it becomes subtraction. That's why there is addition here and subtraction there. The power was 3 over 4, so it has to be on both. So with that, I can simplify further. Remember, this ln e is 1, so this will come this side to come up with x, which is there. The rest will remain as they are. So next is now to differentiate. So when I differentiate, I'll come up with dy dx being equal to, so when I differentiate to x, I'll come up with 1, which is there. This 3 over 4 is a constant, so it remains there. Then differentiate ln of x minus 2, I'll come up with, okay, to differentiate the ln of x2, what I'll do, I'll first differentiate what is in brackets. So differentiate x minus 2, I'll come up with 1, which is there, divide by the original x function which you differentiated, and that is x minus 2. Then this minus is there and this constant is there. Then next I'm going to differentiate ln of x plus 2. So to differentiate it, I'll say, look at what's in the bracket is x plus 2. So when I differentiate x plus 2, I'll come up with 1, which is there. After that, I'll divide by the original function which I differentiated, and that is x plus 2. So next is to get LCM. So LCM is 4 multiplied by x minus 2 multiplied by x plus 2, which is that. So that I will say this LCM divide, this is as if it is over 1, so the whole of this LCM divided by 1, I get this very function 4 multiplied by x minus 2 multiplied by x plus 2. When I multiply that by 1, I'll come up with the very function. That is why you are seeing here 4 multiplied by x minus 2 multiplied by x plus 2. The next is to work on the second term. So when I divide the whole of this LCM by this, you realize that this 4 will cancel with this, and this will cancel with this, so I remain with x plus 2. So this x plus 2 is what I'm going to multiply by 3 times 1. So x plus 2 times 3 times 1 will give me 3x plus 2. That's why you see there 3x plus 2 there. Then this minus will come here. Then next I'll divide this LCM by this. So when I divide this by this, you realize that 4 will cancel, then x plus 2 will cancel. I remain with x minus 2. So this x minus 2 multiplied by 3 times 1 will give me 3x minus 2. That's why you see it there. Okay, so now I've put everything into one quotient. Next is to open brackets and simplify for the numerator. So the numerator will be, when I open brackets, I'll come up with 4x squared minus 16 plus 3x plus 6 minus 3x plus 6. Down, this is the difference of two squares, so it will be 4 out 4 here. Then difference of two squares, it will become x squared minus 4. So the next step is to simplify. So when I simplify, I'll come up with this, which is there. Then now negative 16 plus 6, that is negative 10. Now negative 10 plus 6 is negative 4. That's why you see negative 4 there. Then down, we leave it as it is, which is that. So after that, what I'm going to do, I'll factorize out 4, because 4 is common in the numerator. So when I factorize out 4, I'll come up with this part, and in this part, this 4 and this 4 can cancel to remain with x minus 2 x squared minus 1 over x squared minus 4 as required. So remember, this was the required expression. So that was part A. Now shall go to part B. So part B, they wanted to integrate, but before you integrate, we have to use the method of change of variables. So what you are going to do, we are going to let x squared to be equal to 25 sine squared u. Put square on both sides and take the positive term. I'll come up with x being equal to 5 sine u. So when I differentiate with respect to u, I'll come up with dx being equal to 5 cos u du. So now that I've got dx, I also have to get the new limits. So I'll draw something like a table. One will have x, and for x we'll have the limits, which were 0 and 4. Then we shall have another new variable, which is u, which I've generated, and that means that you go here. When x is 0, come and put 0 here, meaning that sine u is equal to 0. Therefore, arc sine 0 will be 0. Then when x is 4, come and put 4 here, meaning that 4 is equal to 5 sine u. Therefore, u will be equal to arc sine of 5 over 4. Now 5 over 4 is 0.8. That's why you see here arc sine of 0.8. So shall leave it like that because it has recurring angle. Now before we go to the next step, let's see how marks can be awarded for this slide. So M1 will be for expanding to come up with that. Then another M1 for differentiating. Then another M1 for combining into one quotient. Another was getting the LCM. Then another M1 for simplifying to come up with that. Then another B1 for factorizing out 4 to come up with that. Then B1 for getting the factorizing out 4 and the output. So this B1 was supposed to be given at this final step, which was the required expression. Then for part B, B1 for getting the expression for dx. Then another B1 for changing the limits. So now that I've got the dx in terms of u, and we have changed the new, now the new limits will be 0 to arcsine 0.8. So we shall come here and say that this given integral, so the limits were 0 to 4, now the limits are 0 to arcsine 0.8. Why? Because we have now changed to du. So some students make a mistake of changing the limits at the very end, which is not okay. So you have to change immediately this, the dx changes into du. That is when you change the limits also. So next is substitute. Remember we said x squared is equal to 25 sine squared du, which is that. Then this x squared also put 25 sine squared du. Then dx we saw that is equal to 5 cos u du, so we shall substitute there. Now next is to simplify. So you realize that this one, 25 sine squared, 25 minus 25 sine squared u is the same. You can factorize out 5 to come up with 20. I can factorize out 25 to come up with 25 cos 25 in brackets 1 minus sine squared u. But I also know that 1 minus sine squared u is equal to cos squared u. Therefore, square root of 25 cos squared u gives me 5 cos u. Then this one remains as it is. So that you realize that this we can cancel with this and that. So remain with du over 25 sine squared u. But we know that 1 over sine squared u is the same as cosec squared u, so that's why it comes there. But the 25 remains as the denominator, so don't make a mistake of taking the 25 also up. It has to remain there. It is only the sign which goes up to become cosec squared u. So that I have to integrate cosec squared u. When I integrate cosec squared u, I'll come up with negative cot u. So when do we put this negative? As long as after integrating the final trig function has co in it, just know that there must be a negative. So it is different from differentiation. Differentiation, you look at what you are going to differentiate. If it has co, then just know that the final answer after differentiating must have a negative. But for integration, you don't look at what you are going to integrate. You look at what you have, what comes out after integrating. So if what comes out has a co in it, then the answer must have this negative. So don't forget that negative if it has co. Okay, so cos squared, integrating cos squared u is the same as negative cot u. Now this 25 remains as the denominator. Now next is to substitute the limits. So I'll substitute, put this one here, I'll come up with negative cot in brackets arcsine of 0.8 minus, and then put this here, I will come up with cot 0, which will be 0 here. But the 25, don't forget it as the denominator. Then next I can use a calculator. I realize that this cot of arcsine 0.8 is the same as 3 over 20 over 100. So this divided by 25 is the same as negative 3 over 100. So from this step to this step, you can use the calculator, but always be mindful of the board mass, because the calculator uses board mass, so you have to make good use of the brackets. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for changing variable, M1 for simplifying to come up with that, and M1 for integration to come up with that, M1 for substitution of the limits, and A1 for the output. So what to remember is that don't hurry to change this into an angle, because the angle had recurring decimals, so you have to leave it as arcsine 0.8 to avoid those many decimal points. So part A required use of laws of logarithms and to decongest the given expression, because natural logarithm is also logarithm, and then to differentiate term by term and differentiate and simplify to a given expression. So mathematics, you have to follow step by step. First, they wanted you to use the laws of logarithm to decongest the given expression. After that, you had to differentiate term by term, and after that, you had to simplify until you get the required expression. Then when it comes to part B required using a suitable substitution, what we call change of variable, to evaluate a definite integral. So definite means that it has limits. Part A was popular, but part B was not. I think the problem came in changing limits. So let's see the weakness of candidates. So some candidates failed to apply the laws of logarithms to expand the bulky expressions. Some students didn't. They just chose to struggle to differentiate as it was, which was not okay. So they had to get stuck. Then there also candidates fail to identify a suitable substitution. So as long as it is not expression, you have to first say x squared is equal to 25 sin squared u. Then another problem is that candidates fail to convert the limits. So as long as you change the variable, you must change the limits too. Always remember that. So advice to teachers is to emphasize the laws of logarithm. Then also to illustrate the algebra involved in simplification of fractions. Then guide students on types of substitution suitable for a given integrand. And also to use systematic approach. Know this word, systematic approach to methods of integration. So know which method to use, because integration, various integrals have different methods of approach. So you have to be systematic and understand which method to use on which integral. So that was question 12. Now we shall go to question 13. So question 13 says 4 points have coordinates A, which is that, B, which is that, C, which is that, and D, which is that. The lines AB and CD intersect at P. Determine part A the vector equations of lines AB and CD, then part B the value of K, and part C the coordinates of P. So for part A, we want the equations of the lines. So we shall say that for line AB, you have to know that AB is equal to OB minus OA. So I'll come and substitute coordinates of B in vector form and coordinates of A in vector form, then I subtract. So subtracting 13 minus 3 gives me positive 10, 9 minus 4 gives me positive 5, 2 minus 7 gives me negative 5. So that I realize, I'll come and say that my equation of line AB is equal to R1 being equal to OA plus a constant which is lambda multiplied by AB. So what you should realize and what you should never forget is that this letter which starts here, the direction is the one which must be the position vector. So that is mistake is most students make it. So if you put here OB, it implies that here it has to be BA. Why? Because the letter which starts is the one which gives you the position vector to put here. So now that I've used AB, it means that here I must put OA. So that was R1. Therefore R1 I'll come and substitute my point OA is that, and the direction vector is that. So now we shall go to line CD. So for line CD I'll come and say that CD is equal to OD minus OC. So OD is that, OC is that. So when I subtract 10 minus 1 is 9, K minus 2 is K minus 2, 6 minus 3 is 3. So that is my direction. So I come and say that R2 is equal to OC plus mu. So I think we realize that we are using different constants. So I used lambda, here we used mu. So if you use the same constants, that will also not be okay. So the constants must be different. And I think to realize that the letter which starts here is what you choose as your position. So if you want to use OD here it has to be DC. So always remember that. So next is to substitute. So we shall say that R2 is equal to this OC plus mu this direction vector. So those are the equations of lines AB and CD. So before we go to the next slide, let's see how marks can be awarded. So B1 for the direction vector AB and B1 for the vector equation AB. B1 for direction vector CD and B1 for equation vector CD. So next we have that at the point of intersection, the two equations have the same values of x, y, and z. So we shall equate the two lines to come up with that. So next we shall use equality of vectors. What does that mean? It means that for the first row, it should be 3 plus lambda 10 plus 10 lambda is equal to 1 plus 9 mu. So I'll come and write that. This implies that when I take everything on one side to put the constant on this side, I'll come up with 10 lambda minus 9 mu is equal to negative 2. So what I've done, I brought this through this side to become 1 minus 3, which is negative 2, and brought this one this side to become a negative 9 mu. What about for the second line? For the second line, we shall say 4 plus 5 lambda is equal to 2 plus k minus 2 mu. This is that line, so I'll rearrange to get the second equation, which is 5 lambda minus mu in brackets k minus 2 is equal to negative 2 as my equation 2. What about for the third line? For the third line, I've said 7 minus 5 lambda is equal to 3 plus 3 mu, which is that. So when I rearrange, I'll come up with equation 3, which is 5 lambda plus 3 mu is equal to 4. So now that I've got 3 equations and 3 unknowns, so I can substitute to get the value which they want. So when I say for the first equation and I add it to the third equation multiplied by 3, I'll come up with that. For example, this multiplied by 3, I'll come up with 15 lambda. And when I look at the first equation here, I have 10 lambda, so 10 lambda plus 15 lambda, it gives me 25 lambda, which is that. Then here when I multiply this by 3, I come up with 9 mu, and here I have negative 9 mu. So negative 9 mu plus 9 mu will give me 0. That's why there's no mu here. Then this multiplied by 3, I'll come up with 12. So 12 plus negative 2, I'll come up with positive 10, which is there. So when I make from the subject, from that will be 2 over 5. Now from equation 1, which is this, I will substitute for lambda and get the value of mu. So the value of mu will be equal to 2 over 3. So before we go to the next slide, let's see how marks can be awarded. So M1 for equating the two vector equations, another M1 for equations 1, 2, and 3, extracting out those equations. Then B1 for the value of lambda, B1 for the value of mu. Then we shall say that from equation 2, we shall substitute for mu and lambda, so to come up with that, I think we say that we have only k, which is an unknown. Therefore, when I simplify and make k the subject, I'll come up with the value of k being equal to 8. So basically that's what they wanted in B. Now let's go to part C. So at the point P, mu is equal to 2 over 3. Therefore, from R2, I'll come and substitute for mu and also for the value of k. Therefore, I'll come up with mu was 2 over 3 and k was 8, which I've got here. So when I substitute, I'll come up with that after simplifying. Remember, this 2 over 3 multiplies each entry inside. So 2 over 3 times 9 gives me 6. 2 over 3 times 6 gives me 4. 2 over 3 times 3 gives me 2. So when I add these two vectors, I'll come up with 7, 6, 5. Therefore, the coordinate of P will be 765. So most students stop at this, but this is the position vector of P, but they wanted coordinates, so you have to conclude in that form. So now let's see how marks can be awarded. So this M1 for substitution here, and this A1 for the value of K, B1 for vector of P, and B1 for the coordinate of P. So the question required obtaining the vector equation of lines and finding their point of intersection. So it was very popular, meaning it appears frequently in the previous past papers. The weakness to candidates is that was forming and solving the intermediate simultaneous equations, which was a very big challenge. Then also candidates fail to extract coordinates from position vector. So most candidates, what they do, they stop at the position vector, which is not okay. So in that case, you'll miss the final mark, which is the accuracy mark. So you have to extract the coordinates from the position vector. Then advice to teachers is to emphasize conditions for equality of two vectors, and also distinguish between position vectors and coordinates of a point. Then also expose students to the component unit vector form and column vector form of equation of lines. So that was question 13. Now we shall go to question 14. Question 14 says that expand this up to the term in x squared. Then hence find the value of this to 4 significant figures. So we need to first put this into this using laws of indices. So square root is the same as to power half, so the square root is on both. So the first one will be 1 plus 2x raised to the power half multiplied by 1 minus x raised to the power negative a half. So negative because it was the denominator, and we have brought it to be the numerator, to be up. So next is to expand each of these independently. After that we shall multiply the two. So when I expand, I'll use this formula. This is a formula which is found in the mathematical tables. So if you have a remember in Uneb, they will give you those mathematical tables, so you have to open and quote that formula. And now that we shall now use it to expand. Now to expand, you have to compare. In this case, you realize that 2x is the same as ax. So where there is ax, you'll put there 2x, and where there is n, you'll put there a half. So when you do that, this is 1, this n is a half, then ax is 2x. Here n is a half, n minus 1 is a half, 1 is a half minus 1, which is negative a half. Then ax is 2x. This is square, this is 2 factorial. So you have to follow the formula as it is. So that was this. Next is to simplify. When I simplify, I realize that this is that. Then a half times 2x is equal to x. Then a half times negative a half is negative a quarter. So that negative a quarter, but here we have 2x squared, which gives you 4x squared. So therefore, negative a quarter times 4x squared is equal to negative x squared. But remember, we still have 2 factorial here in the denominator. So negative x squared divided by 2 is the same as a half x squared. What about this term? So this term still we shall compare. You realize that here it was plus, but here there is minus. What does that mean? It means that the whole of this will be replaced by that. So where there is ax, we shall put there negative 1x. So this one is there. This n is, now our n is negative a half. That's why you see here minus. Then ax is negative 1, that's why you see negative 1 there. Then n is negative a half, that's why you see this minus. Then n minus 1, you'll see negative a half minus 1 to give you negative 3 over 2. Then ax is negative x, which is that. Then next is put this factorial there and this power there. Now we are stopping at x squared because the question wanted you to give the answer up to expand up to x squared. So next is to simplify. So this will be 1 plus a half x plus 3 over 8 x squared. So how does that 3 over 8 come from? So this is, remember, this is negative a half multiplied by negative 3 over 4, 3 over 2 gives you positive 3 over 4. Now that positive 3 over 4 multiplied by this 1 over 2, because 2 factorial is 2, as the denominator, so it will be negative 1 of, it will be 1 over 2. So positive 3 over 4 times 1 over 2 gives you 3 over 8. Now this negative x squared becomes positive x squared. So before we go to the next slide, let's see how marks can be awarded here. So M1 for this expansion, B1 for the simplifying to get the output, M1 for this expansion, B1 for simplifying to get the output. So now the next step is to multiply this and with that. So let's see that in the next slide. So this one will be equal to this expansion of 1 plus 2x raised to the power half multiplied by the expansion of 1 minus x raised to the power negative a half. But remember, they told us to expand up to x squared, so we must remember that. So how do we expand? First of all, we are going to say this one multiplied by the whole of this will give, you'll get that. Then this x multiplied by the whole of this, you come up with this. So it will be more, but remember that when you reach x squared, you stop. For example, let's see how that comes about. So this x multiplied by 1 gives you x, which is there. Then also this x multiplied by a half x gives you a half x squared. Now if you multiply this x by this, you would have got 3 over 8x cubed. But remember, they told us to expand up to x squared, so you don't add another term for x cubed. Always remember that. So that's why you are putting these dots. Okay, what about this? So negative a half x squared by 1 gives you this negative a half x squared. Now when I multiply this negative a half x squared by this, I'll come up with x cubed, which is not required. And also when I multiply this by this, I'll come up with x power 4, which is not required. So that is why we only put this. So that is how they expand. Next is to collect like terms. So when I collect like terms, I'll come up with 1 plus 3 over 2x plus 8 over 3 over 8x squared. So that basically that is the expansion. Next is to go to the hence part. So for the hence part, the first thing to do is to find out which value of x to use. So when you look at this, 1.04 is the same as 1 plus 2 times 0.02, and also 0.98 is the same as 1 minus 0.02. So when I compare this with this, you realize that x is 0.02. Also, if I compare this with this, you realize that this x is equal to 0.02. Therefore, the value of x we use will be 0.02. So you come here and substitute for x, so where there is x, you put there 0.02 to come up with this value. But remember, in the question they specified the accuracy of 4 significant figures, so you have to count 1, 2, 3, and 4. Then we round off to that. So this value is less than 5, so it will become 1.0304 significant figures. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for this substitution, in this M1 for multiplying, so to get this first term, to get this second term, and to get this third term. Then B1 for the final output, B1 for the value of x, B1 for substitution, A1 for output, but this output must be to 4 significant figures. So the question required expansion of a quotient involving fractional indices and use it to evaluate given related mixed figures to required significant figures. So the question was popular, meaning it appears frequently in the previous past papers. However, candidates had these weaknesses, so they failed to express the quotient as a product when using binomial theorem. So it has to be expressed using as a product by using those negative indices. Then 2, they failed to expand to the required number of terms, so we have to expand up to x squared. Then 3, they failed to identify the value of x in the evaluation, so identifying that x is equal to 0.02 was also a challenge. Then also they failed to distinguish between significant figures and number of decimal places. Most people, instead of rounding off to 4 significant figures, they rounded off to 4 decimal places. So advice to teachers is: 1, emphasize that in the binomial expansion, a quotient must be expressed as a product. So this is very, very vital. Then encourage students to use formulae from the mathematical table. I think we realize that the formula we quoted to expand the given expression was from the mathematical table. I think I've showed you in this video how you can use that formula to come up with the expansion which is required. So that was question 14. Now we shall go to question 15. So question 15 part A says differentiate y equal to 2x squared plus 3 from first principles. That was part A. Now part B says a rectangular sheet of 50 centimeters long and 40 centimeters wide is of that 50 centimeters long and 40 centimeters wide. Then they say that a square of x centimeters by x centimeters is cut off from each corner. The remaining sheet is folded to form an open box. Find the maximum volume of the box. So let's start with part A. So part A, differing from first principles, we shall say that let small change in y be this symbol sigma y be the small change in y when x is incremented by this sigma x. So we shall start by writing the given expression y equal to 2x squared plus 3, or that we shall increment each on both sides. So this becomes y plus small change in y. Then here where there is x, we put there small x plus small change in x. After that, we shall open brackets here to come up with 2x squared plus 4x times small change in x plus 2 times small change in x squared plus 3. But we know that y is equal to 2x plus 3. So what shall we do? We shall come and say that this y cancels with this 2x squared plus 3 to remain with small change in y being equal to this plus that. Then next is to divide both sides by small change in x. So when you do that, this is what you are going to come up with. So this divided by small change in x gives that, this divided by small change in x gives that, and this divided by small change in x gives that. So next is simplify. This and this can cancel, and this with this reduce to become 2 small change in x. After that, we have to make an assumption that dy dx is equal to the limit as small change in x tends to 0 of small change in x, small change in y, small change in x. What does that mean? It means that where there is small change in x, you put there 0 because it tends to 0. Therefore, dy dx will be equal to 4x. So that was part A. Now let's see how marks can be awarded for part A. So M1 for the expansion, then M1 for dividing throughout by small change in x, then this is expression of small change in x, small change in y, then this one is for the expression of dy dx. So that was part A. Now let's see part B. So part B said we have to read carefully so that we can interpret it. So a rectangular sheet is 50 centimeters long, so that's the length, and 40 centimeters wide. This is the width, so length is 50 centimeters, width is 40 centimeters. A square of x centimeters by x centimeters is cut off from each corner. Know that. Then the remaining sheet is folded to form an open box. Note that. Find the maximum volume of the box. So this question is easily done by making a sketch. So for part B, the first thing to do is to make a sketch. So let's first draw a rectangle which is 50 by 40. Then after that we shall cut off squares of x centimeters at each corner. So let's do that. Okay, then after that the remaining length will be now 50 minus 2x, because here there is this x and this x which has been cut off, so x plus x is 2x, so remaining, the total was 50, now the balance will be 50 minus 2x. Similarly for the width, they have cut off this x and this x which is 2x, so it was 40 originally, but they have removed 2x, now the remaining length will be 40 minus 2x. Therefore what comes out next will be a rectangle which is of that form, an open box. So that is an open box which has length of 50 minus 2x, width of 40 minus 2x, and height of x. Therefore for the box we shall come and say that the length is that, width is that, and height is that. Therefore the volume will be the product length times width times height. So length times width times height. Therefore when I expand, I'll come up with, first of all I'm going to expand these two brackets to come up with that, then this x will also remain outside, and after that I'm going to put this x inside to come up with that. So that is the expression for volume. Now before we go to the next slide, let's see marks for this part. So this part, the only mark was for getting the expression of volume. So we have got the expression for volume. Now we shall remember that for maximum or minimum volume, the derivative must be equal to 0. So we are going to differentiate this volume to come up with 2000 minus 360x plus 12x squared equal to 0. So this is a quadratic. We can use bulldozer method to get the values of x. So when I use bulldozer method, the values of x will be this and that. But remember, we have to find out which one is maximum and which one is minimum. So you come and say that volume is that, therefore when x is this, what will be the volume? So the volume will be got by substituting for x here like that to come up with negative 564.2255. What about when x is 7.3624? So I come and substitute for x here to come up with 6563.89520. So when I compare this value and this value, realize that this is the bigger compared to this. Therefore we shall come and conclude that the maximum volume is equal to 6563.89502 centimeters cubed. So basically that's what they wanted. Now let's see how marks can be awarded. So this M1 is for differentiating, another M1 is for equating to 0. Then M1 for solving the quadratic. So you have to show this part of solving the quadratic. Then B1 for both values of x. Then B1 for volume when x is that. Then another B1 for volume when x is that. Another one for concluding. So part A required differentiation of a simple polynomial from first principles, and part B required forming an expression for the volume of a cuboid from the given information and use differentiation to find the maximum volume. So the question was not popular, meaning that it appears less frequently in the previous past papers. So candidates' weakness is that they failed to obtain the correct expression for fx plus delta x. So here instead of delta, for me I used sigma x. So but all is okay. Then two, that they failed to form the expression for the required volume. So obtaining the expression for the required volume in terms of x was also a challenge. Advice to teachers is to emphasize that the increment is on x and not on the function. So most students, they're writing 2x squared plus small change in x, which is not okay. So increment has to be on x. That is why in my solution I put there brackets. Then 2 advises to systematically expose students to applications of differentiation. So that was question 15. Now we shall go to question 16. Question 16 says that find the integral of ln x over x squared with respect to x. Then part B, solve the differential equation of dy dx plus y cot x equal to x, given that y is equal to 1 when x is equal to pi over 2. So part A, we shall say that what you should realize that now the method to use is integration by parts. So let u be equal to ln x and dv dx be equal to 1 over x squared. Therefore du dx will be equal to integral of this, which is 1 over x, and v will be equal to the du dx will be the derivative of ln x, which is that, and v will be the integral of 1 over x squared, which is negative 1 over x. After that, I'll quote the formula for integration by parts, then I'll substitute. So u dv dx is equal to the given integral, then u is here and v is here. So when I multiply the two, I'll come up with this negative ln x over x minus then v du dx. So v is here and du dx is here. So when I multiply the two, I'll come up with this with respect to x. So the negative this and this negative is positive. Therefore integrating 1 over x squared is equal to negative 1 over x, which is that. Don't forget the constant of integration. So basically that's what they wanted, and now let's see how marks can be awarded. So B1 for both v and du dx, then M1 for substitution and M1 for integrating that negative 1 over x squared, and A1 for the final output, the whole of this with a constant of integration sin. So that was part A. Now let's go to part B. So part B, this was the differential equation they gave and they wanted you to solve it. So the first thing to do is to identify the method to use. So in this case the method is integration using an integrating factor. Why? Because this the e is not separable, and 2, it is not homogeneous. So if it was separable, it means that you could put values of x this side and variables of y this side, so it can't happen. Then if it was homogeneous, it means that it will have the same dimension. For example, here it is 1, here dimension of y is L, dimension of x is L, so we have 1 L L. The dimension of cot is 1, so we have L L1, which is not homogeneous. If it was homogeneous, all would have been L L L or 1 1 1. So in that case, the only option, if it is not separable or homogeneous, the only method to use is the one for integrating factor. And this method of integrating factor has steps followed. So we are going to look at all those steps followed step by step until we come to the required solution. So we shall say that integrating factor is equal to e integral of cot x. So this cot x comes from the coefficient of y. So the coefficient of y is cot x. That's what you're going to integrate, but it has to be exponential. So when I integrate cot x, I'll come up with ln of sine x. Now this e raised to the power ln will cancel to remain with this, only sine x, which is here. So that is also an identity under exponentials. So after getting the integrating factor, next is to multiply that integrating factor through the given differential equation. So let's do that. We shall come up with that. So sine x by this gives this, sine x by this gives this, and sine x by this gives that. Now after that, we are going to apply an identity that the whole of this expression on the left hand side is equal to y times the integrating factor. So integrating factor is that, and y is here. So when I apply the 2, I come up with y sine x. So ddx of y sine x is equal to the whole of this expression on the left hand side. For the right hand side, it remains as it was. So next is to put integrals on both sides. So when I put integrals on both sides, I'll come up with that. And from there, I'll have to get the integral of x sine x. So this is integration by parts, but since this one can be easily integrated, we can use the special case of using a table. So when we tabulate, we shall have column of sine, so we start with plus followed by minus followed by plus and so on. Then for the part of differentiation, we shall have this, which is x followed by 1. When I differentiate x, I'll come up with 1. When I differentiate 1, I'll come up with 0. So this is where how you know where to stop. Then what about for the column of integration? Integration, I'll put there this first. Then when I integrate that, I'll come up with negative that. And when I integrate that, I'll come up with negative that. So after that, I'll come and start and substitute. So that means that this cancels, integration and differentiation cancels to remain with y sine x, which is there. But for this other side, it will be the integral of this. So how does it come about? You'll come and say this times that to come up with negative x cos x, which is here. Then this times that, it becomes positive sine x, which is there. Then because it was an indefinite integral, you have to add the constant of integration. But the good thing, we are told that y is equal to 1 when x is pi over 2. So we shall come and say that y put 1 where there is x put pi over 2. So that's why you put this x pi over 2, this x pi over 2, this x pi over 2, this x pi over 2. So that I realized that sine pi over 2 is 1, so 1 times 1 is 1, but cos pi over 2 is 0, then sine pi over 2 is 1 plus c. So realize that c is equal to 0. Now that I've got c is equal to 0, I can come and write my solution, which is that. So basically that's what they wanted. Now let's see how marks can be awarded. So this M1 was for getting the integrating factor, then M1 for multiplying through by IF, then M1 for simplifying to come up with that, then this B1 for tabulating for that, and also B1 for tabulating that. Then M1 for the outputs of both integrands, so M1 that and M1 for that. Then A1 for the required solution. So part A required integration by parts, and part B required solving a first order non-exact linear differential equation. So the question was popular, meaning it appears frequently in the previous post papers. So the weakness of candidates is that is one wrong choice of the parts to integrate. So the one which can be easily integrated is one you should make to be dvdx. Then another weakness is the omission of coefficient and constant of integration. So as long as it is an indefinite integral, the constant of integration must be there. Then 3 is identifying the suitable integrating factor was a challenge. So the integrating factor to use will be integral of exponential of the exponential of the integral of the coefficient of y. Then another one is candidates failed to simplify the expression after integration. So advice to teachers is to guide students on identifying the parts when integrating by parts. Then 2, expose students to all the methods of solving differential equations. So that brings us to the end. So brief summary is that the paper comprised of 2 sections, A and B, and section A had 8 compulsory short answer questions, and section B had 8 extended answer questions, and Candace answered only 5 questions. Always remember that as you're going to sit for your examinations, answer only 5 questions. The questions were from the topics of algebra, geometry, trigonometry, analysis, and vectors. Always remember that questions must come from this. So 2 questions in section algebra has 2 questions in section A, 2 in section B. Geometry has 1 question in section A, 1 question in section B. Trigonometry has 1 question in section A, 1 question in section B. Analysis has 3 in section A, 3 in section B. And vectors has 1 in section A, 1 section B. That makes the 16 questions. So the paper was of the same level of difficulty as that of the previous year, which was 2018, and the time of 3 hours allocated for the paper was adequate. So these are the well done questions, and these were the poorly done questions, and these were the most attempted questions, and these were the least attempted questions. So I believe you have understood something, and wish you the best as you sit for your current Uneb examinations. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on Uneb of 2019 of paper 2. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video for Uneb 2019 paper 2 has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, that can all benefit us, a family.